Okay, so this chapter will kind of be the same as other ones in the sense that you're going to need to know how to factor. So I want you to write this down. Let me zoom in a little bit. And as long as you follow these rules, then you'll be good for the first section of simplifying. So you're going to factor the top. You'll know it's factoring if you can add or subtract. Well, not every time, but most of the time. Then you'll factor the bottom, and then you'll cross off what is the same, only if it's being multiplied. And some of you go, that seems simple enough. Why am I going to write that down? Because I want to tell you your future for this chapter. You're going to be simplifying these fractions. You're going to be multiplying and dividing fractions. You're going to be adding and subtracting fractions. Then you're going to be solving fractions. So they're all going to have a little bit different rules. And it is very easy to mix those up. Okay? So let's get started from what we're going to do. So number one, factor the top. Let me zoom that in a little bit. Well, remember, we can only factor the top if it's being added or subtracted, so I can't factor the top. Factor the bottom, only if it's added or subtracting. So now I'm going to cross off what's the same. So when I look at what's the same, I see that 14 and 35 both divide by 7, 2 and 5. So I'll rewrite this fraction. I have 1 n on top, 2 on bottom, so I have 1 more left on the bottom. And that's my answer. That's how we're going to get started, okay? We're starting off with what we've already done before, but it's called a rational expression. A rational expression is a fancy way of saying it's a fraction, okay? And we're also going to say this part, but we're going to get to that in a little bit, what makes it undefined. Right now, what I want us to do is just simplify it. Let's go to this one. 11 goes into 66, 11 times. There are 7 more x's on the bottom, 6 is on the bottom, 1 and negative. You can either put the negative there or you can put it on top, but do not put it on the bottom. Okay, last one. 28 and 16 are both even, so they divide by 2. 14 and 8, divide by 4, just kidding. 7 and 4, and there's 1 more a on the bottom, 7, 4. This time I'll put the negative like this, so we can see it differently. Okay. Now we get to number 7. Well, how does number 7 affect us? Well, because whenever there's adding and subtracting, like we see here, there's a really good opportunity for you to be factoring. So there's different types of factoring. So let me remind you. There's GCF, which is sometimes when we make the box and find out what's the same. There's magic X. There's also the magic X where you have a number in front. And then there's the square root, which is the difference of squares, okay? There's actually I don't even know if I put it in here, but of course there's difference of cubes, sum of cubes, but these are the basics. All right, so I look here and I'm going to factor the top. What number goes into 50 and 60? 10. Now I'll be left with 5r plus 6. Excuse me. What number goes into 20 and 30? 10. And I'm left with 2r minus 3. If you want to do the box to see 10, 2r, 10, 3, 10, 10, whoosh, great. Now I have to cross off what is the same. I can only cross off the same if it's being multiplied. So if I look, 10 is being multiplied to all that. 10 is being multiplied to all that, so I can cross them off. Then I'm left with 5r plus 6, and I'm left with 2r minus 3. Okay, let's look at number 9. I'm going to be factoring. So if I'm going to factor, I see this as magic X. So I'm going to come over here with my cute little magic X. Some of us don't need the magic X anymore. Some of us do. Whatever. You need it, use it. You don't, don't. X minus 4, X plus 2. And then magic X the bottom as well. Negative 2 and 1 is 2 and negative 1. Sometimes doing the magic X just makes it easier for our brain, makes us feel like we get the game a little bit better. So now, I factor the top, I factor the bottom, now I'm going to cross things off. What can I cross off? Whatever is being multiplied. This whole thing is being multiplied to that. This whole thing is being multiplied to that. I can cross them off. I'm left with x minus 4 over x minus 1. Now some of you go, well, I know this, I can cross off the x's. Well, I can only cross off what is the same, what is being multiplied. This is being subtracted. Can't do it. This is being subtracted. Can't do it. What if I had this and this? Could I do it now? No, because this 3x is being subtracted. This 6x is being subtracted. So I cannot do that unless that whole darn thing is being multiplied. Okay? Let's go to number 11. Take a 6, p minus 8. Now remember how I said if it's adding or subtracting, you can factor? But I actually can't factor that one. But that's the only time you will even think about factoring. So wait a minute, I can't cross things off. Yes, I can. Yes, I can. So if you look here, this is positive, this is negative. This is positive, this is negative. So these are opposite, and these are opposite. If you remember from before, if you take out a -1, then now that would be the opposite, and that would be the opposite. No, positive, positive, negative, negative, they are the same. 6 divided by -1, -6. All right, let's go to number 13. Look at the top. Let me cross this off, because sometimes I can get distracted by looking at the other one. So let me zoom in a little bit. I notice they're all even. Since they're all even, I take out a 2.
If you feel sick, stay home until you are free from symptoms. Be responsible.
But then I look here, and I can magic exit. So I always have to see. Now some of you go, how do you know if you can magic exit? Well, you have to look and you have to try. If I give you the fraction 3/4, how do you know that you're done? And you're like, well, because you're done. Well, how do you know? Because you can't think of any numbers that divide into 3 and divide into 4 that are exactly the same. But if I give you 3/9, how do you know you can simplify that? Well, because you're familiar that both of them divide by 3, because you've seen it so many times. So it's the same kind of thing. So notice what I did here. Once I factored that, I crossed it off so I wouldn't look at it anymore. Now I have over. Okay, that looks like a good little workout. So give me a second. I'm going to pause this one to see if I can figure out, because I feel like it's 3, but let me just check. It was 3. Oh, oopsies. They also all have an x. So that should be 3x, 7x squared minus 47x plus 30. And then I'm going to have to come over here, and I'm going to have to magic exit. 2 numbers that multiply to get 210 and add to get -47. Now, I bet you would agree that this looks like a pain. So I'm going to do some guess and check. I'm going to use some logic here. Okay, I could start listing all the numbers that go in. 1, 210, 2, 105, 370, and so on and so forth. I know that 10 and 21 work. And I could keep going, which also means that 5 and 42 work, because if I half that, then I double that. And so far, oh, I am seeing 47. Oh, I ended up getting it. Okay, so let's do it that way, and then I'll show you the logic way. So then I go 42 and 5, negative, negative. So then I end up with 7x minus 5, 7x minus 42, divide by 7, divide by 7, 7x minus 5, x minus 6, bring down the 3x. Now, what if I had this, let me re-show it, the 7x squared minus 47x plus 30. Okay, let me zoom out a little bit. And let's say I go, you know what, Mr. Rifkin, I wouldn't have gotten the 5 and the 42. I want to remind you what is up top. And some of you might not understand this way, and that's fine. As long as you know one way, then you're good to go. I'm guessing, since this whole concept is about crossing things off, that I'm going to be crossing off either the x minus 5 or the 2. So let's say I think it's the x minus 5. So I'm guessing that if that's x minus 5, if that's 5, that's positive 30, that would have to be negative 6. If this is 7x squared, this would have to be 7x minus 6. Now, how would I know if I'm right? That's negative 6, and that's negative 35. That will not give me negative 47, so I was not a good guesser. So let's try again. This time I'm going to say, okay, I think it's x minus 6. If I think it's x minus 6, and that's positive 30, that would have to be negative 5, because negative 5 times negative 6 is 30. And then if I'm going to get 7x squared, that would have to be 7x. Negative 5x, negative 42x does give me negative 47, so that's my guess. I like doing it that way, okay? But if you want to factor it, great. So let's go back into zooming in and start now with this whole mess, crossing off what's the same. So x minus 6 is the same. Now, this is being added, that's being subtracted, can't do it, okay? So I don't really see anything else that I can cross off. So here's what I like doing. I like going through and highlighting what I didn't cross off before I write the answer to make sure I can keep track of everything. And some of you go, Miss Rifkin, why are you doing that? That seems silly. I can see it. And I completely understand. But next section, you're going to be doing twice as much. So it's going to be a lot more difficult to keep track of things. So I thought, hey, might as well start the habit now of highlighting what's left. So that's number 13. Let's do number 15. I notice they all divide by 5, and I notice they all have an n. 7n squared plus 3n minus 10. This I can take out of 5n, and I'd be left with 3n minus 1. Now, I want to use the strategy that I used in the previous problem to see if it'll work, because I don't want to magic X that. So my guess, because that's a 3n minus 1, is that 1, because I can keep factoring this, is 3n minus 1. If one of them is 3n minus 1, then that means this would have to be negative 10. Positive 10, because 10 times negative 1 is negative 10. Okay, and then I go, okay, well, I have to get 7. Can I get 7? No. Shoot. That way actually didn't work this time. So I'm just going to have to magic exit myself. Negative 73, which is 10 and negative 7. 7n plus 10. 7n minus 7. Divide by 7. 7n plus 10. N minus 1. Now, here's the truth. Would anything match the bottom? No. So technically, did I even have to factor that? Nope. And I knew that because I couldn't find a match. The whole idea is to simplify it. And some of you go, what? Okay. Let's go back to 3. Let's go 3/10. And you go, can I simplify it? No. But 10 is 5 times 2. And you're like, well, that's great. But it's not going to match up with a 3. So why would I even care? You're done. Where if I had 3/9, that's 3 times 3, and that's 3 times 1. It is important to actually, quote, factor the 9, because they would have something the same. All right? So then I go back to here, and I go, oh, these two are the same. And then I'm going to erase this pencil. And I'm going to write the final answer here. 7n squared plus 3n minus 10 over 3n minus 1. Okay, so now the problem is in all of these, I did not state what makes it undefined. What makes something undefined is when you have a 0 in the denominator. You can't have one piece of pizza from no pizza. So what do? You set the denominator equal to 0, the denominator equal to 0, the denominator, the denominator, the denominator. Guess what? Oh, there is no denominator. We'll get to that. The denominator, the denominator. What we're doing is we're trying to figure out what value will make it so that, here's the deal. Here's the answer, 2 over 5n. What I'm saying is that n could be any number in the whole wide world, except n cannot be 0. Because if I set 5n equal to 0, I get 0. So that means if n was 0, this wouldn't be a possible answer. So my final answer is 2 over 5n, comma, when n cannot equal 0. If I set this equal to 0, so I'm going to do that. And you know, I think I'm going to do it in the next video when I talk about homework, okay?